Hi guys, Dave here, G7IYK. I've got my Micro PA50 with the lid ripped off here. Pretty easy to remove, 4 bolts, each corner, M3 hex head. So just an Allen key, pop them out, lid comes off. Very, very simple. It's a very nicely, I was quite impressed with the Micro PA50 in terms of build quality. It's very nicely made. There's all the output filtering. There's your FET PA transistor stages, matching, and your various relays. It's really nicely made. It's a nice little bit of kit for the money. I think it's great. So yeah. So the first question I suppose we ought to ask is why am I attempting to why am I reprogramming the firmware? Why would I do that? I mean, I bought this quite a while ago. I could forget, maybe a couple of years ago, and it came with firmware version 1.9, which is what it displays on the flash screen, on the splash screen when you power it up, and it's worked perfectly. It works absolutely fine. The only little problem, which I've highlighted in another video where I paired this with a Zygu 6100, is that one of its protection modes is over SWR, or excessive SWR, or reflected signal, and it seemed to kick in about an SWR of about 2 to 1, give or take, which was a little sensitive, especially on certain bands. So what would tend to happen, especially if you were operating, I used to use ham sticks or a 5.6 meter telescopic on the car, not always terribly well matched, was that the over SWR would trip out, and there were lots of people sort of saying it was a problem, and they were correct. It was a bit of a problem. I mean, I sort of got round it by adding an external tuner, so it didn't really affect me. However, and there was a hardware modification. There was a workaround. If you look at this resistor over here, it's R35, I believe. This resistor is part of the forward and reverse path matching network, and you could improve this or mitigate this sensitive SWR trip by shunting this resistor, basically. So there's plenty of videos out there that show of people shunting this resistor to make it less sensitive, and yeah, that worked. In fact, you can see evidence of the fact that I actually did perform this modification and did shunt this resistor. However, that's probably not the best approach, and what's happened subsequently is that a new firmware release has been produced for the Micro PA50, which has fixed this over SWR issue, apparently. So the purpose of me reflashing is to fix the over SWR sensitivity issue properly, which is in firmware, rather than performing some sort of hardware sort of hack. So I've removed the resistor that I had across here, and now I'm going to reflash the firmware from 1.9 to 2.8 to fix the problem properly. I hope that makes sense. So yeah, so this is the front of the PA50 where the LCD is, and here's the rear with the RF connectors and the power connector and the fan. If you look at the backhand right hand corner, you can see a little white connector here, which is the fan connection. Now you can unplug this if you want a little bit more access to this programming header. So what do I mean by programming header? Well, there's a 5-pin header back here, and that gives you programming access to the Atmel AT328P microprocessor, which is that little beastie there. That's its brain, if you like. That's the bit that's driving the LCD and controlling everything. And it has onboard flash memory, which is non-volatile memory, and you can reflash it. You can reprogram it with new versions of firmware, like you do with cameras or pretty much everything that you get nowadays. And this is the header that allows you to do it. Now there's 5 pins, of which you only need 4. So the pin closest to the edge of the case is ground. So that's the first one. The one next to it is plus 5 volts. You don't need that. Then there's a DTR pin, which if your USB adapter has a DTR connection, then happy days, you just connect DTR to DTR. In my particular case, this adapter board didn't. It's got an RTS, and so in that case, you connect RTS to DTR. Then you've got RX and TX, transmit and receive asynchronous data. The RX of the PA50 goes to TX of your adapter, and TX of the PA50 goes to RX of your adapter, so they're crossed over. TX to RX, RX to TX. Okay, all good. So let's have a look at this. Excuse me. Let's have a little. Actually, I want to need a little drop of wine. Hang on a minute. That's so much more. That's so much better. So this is the little adapter board I'm using. Let me zoom in on this little fella. Happy days. Right. Now I got loads of these lying around. I bought probably half a dozen of them. I quite like them. There's good build quality. There's loads of them. There's loads of these around. You can get them out of China for a couple of pound. I mean, not even that. You know, they're cheap. I bought this in the UK for about £4, something like that. I'll put a link in the description. I particularly like this one just because I think it's built quite nicely. So what does it do? Well, it gives you USB on the left, and it gives you RS-232 or the TTL version of RS-232 on the right. And I use them all the time. In fact, I bought half a dozen because they're so small and sort of cute. I keep losing the blasted things. I put them in drawers and then I can't find them. So I think I've lost 2 of the 6 I've bought. Anyway, so on your pin header over here, it's got ground RXD, which, as I said, goes to TXD of the Micro PA50. Then you've got TX, which goes to RX of the Micro PA50, so they're effectively crossed. Then you've got a 3.3 volt power line and a 5 volt power line, of which you don't need either of those. Now then this particular board has got an RTS connection and a CTS connection. Now the RTS connection was just a hole in the board, not connected to the pin header. So what I've done is I've added a little header, or added a connection which I can unplug. Thus, so you can see what I've done there. I soldered it. See, I've soldered that little fella in there, like just almost just to go hand in hand with the existing headers, and then I can take my cable here. This particular board, the one I bought in the UK, comes with a set of leads, so you don't even have to buy the leads. It comes with leads, which is great. In fact, it comes with a 5-pin lead, of which I've only used 4 here. So then I just plug that onto there. Et voila. And that gives me my RTS to DTR connection on the Micro PA50. So yeah, that's basically the size of it. And I've done other little video clips subsequent to this one in the same overall video, which showed a bit more detail, the connection here and the reflashing process. But it's very simple. And hocefully once you've reflashed it to 2.8, that should mitigate the problem with the overly sensitive SWR lockout or trip, as it were, which was a little bit annoying. And if you do this 2.8 upgrade, then you can then remove, if you've added the resistor that I pointed out earlier, you can remove it. So yeah, thanks for watching. Cheers.
Oh, hi there, Dave here again, G7IYK. I thought I would highlight the page of the user guide, or the Micro PA50 manual user guide, which details the connection between the Micro PA50 and the COM port adapter. So once you've whipped the lid off the Micro PA50 and you're looking at the front of it, in the back right hand corner you'll see this little white connector. little white connector, which is the fan connection. Now you can unplug the fan connection if you want, again, a little bit more access to these programming header pins, but personally I didn't find it necessary. I just left the fan plugged in. So the manual details 5 connections. You don't need the 5 volts. Believe me, you don't need it. So you only actually need 4 connections, which is handy because my particular COM port adapter came with a 4-port lead. So you need to connect ground. So it's ground of the Micro PA50 to ground of the COM port adapter. You don't need the 5 volts. You need if your COM port adapter has a DTR, then it's DTR to DTR. But as it says down here in this little on this red footnote, if you don't have a DTR but you have an RTS, then you connect this 3rd pin up, DTR, to the RTS line of your COM port adapter. Now TX and RX need crossing over. By that I mean you connect the RXD of the Micro PA50 to the TXD of the COM port adapter, and you connect the TXD of the Micro PA50 to the RXD of the COM port adapter. So from the Micro PA50 point of view, it's TX to the RX of the COM port adapter and RX of the Micro PA50 to TX of the COM port adapter. And that's it, basically. That's the only connections you need, and you don't need the 5-volt line. Yeah, so I think that's clear. Thanks for watching. Cheers. Okay, Dave here again, G7IYK. So I'm assuming you've now got your USB to serial COM port adapter connected, as I indicated. So there's 4 connections you need: ground, RXD, TXD, and also RTS. Some COM port adapters maybe have a DTR line. That's the signal indicated in the Micro PA50 manual, but it also says in there that if your module's got an RTS line rather than the DTR line, then you can use RTS. So I'm using RTS because that's what my module has. As I showed earlier. So here's my directory. I've got a ham stuff directory, and then I've got my Micro PA50 firmware V2.8, which also includes the AVRDUDE programming software. I'll put a link to this. Is stored on my in my Dropbox area, so I'll put a link to it under the video. So if we invoke AVRDUDE, bring that into view and get rid of this. So this is what AVRDUDE looks like. It's a general purpose, generic sort of programming piece of software used for programming a whole range of processors. If you pull here, absolutely, under the Arduino. So basically, we got the programmer set to Arduino, and then under the Arduino programmer, we've got a whole range of possible processors we could pick. The one we want for the Micro PA50 is the ever popular ATmega 328P. So ATmega 328P and Arduino. Now, when you plug your adapter, your USB adapter in to your USB port, if you look under the device manager, so if I invoke the device manager, just give me a second. Okay, here's my device manager. If I look under COM ports, my USB to serial COM port is the CH340, which is COM port 26, and that's appeared here under COM ports. So that's how you know which COM port it is. So you then select the appropriate COM port here. The baud rate is 115200. So you select that in here, just type that in 115200 and your COM port, Arduino and ATmega 328. That is basically it. Oh, you also need to select where your firmware is, obviously. So if I'll do it. Here we go. So I've got it under, the same root directory, Micro PA50. So I got the ham stuff, Micro PA50. And then under the firmware V2.8, and then you want the V2.8 Micro PA50 hex file. A hex file is basically a text file, but it's the firmware. It's a text file representation of the firmware, which in a particular hex format, which is which the programmer uses to actually flash the it's not RAM, it's going to flash the flash memory of the processor. So you select that. So yeah, select open, and it appears here. And that's it. The one thing you do not want to tick under any circumstances is a raised flash and E² prom. Do not tick that. So all this stuff should be left unticked. This should be ticked right, and the E² prom should be ticked right. But do not tick a raise and flash E² prom. So that's quite important. That's basically it. So if I hit program, away it goes. Now you've got your Micro PA50 is powered at this point. You've powered it on the 13.8 volt, or its normal power input. So your Micro PA50 is powered, and that's basically it. You've now programmed it, and if you then power cycle your Micro PA50, you should be running. It will say on the splash screen V2.8. I'll show that in a minute. That's basically it. It's that simple. Anyway, thanks for watching. Cheers. Hi guys, Dave here, G7IYK. This is a very quick snippet just to show the before and after of the reflash. So when I first took delivery of my Micro PA50 before the reflash, on power up, the initial splash screen shows here quite clearly version 1.9, and then after the reflash, you can see that the version now is switched to 2.8, showing that the reflash has been successful. So yeah, that's basically the size of it. Okay, thanks for watching. Cheers.